already we discussed in last class how to identify, right? So how to identify what will be the velocities with if you have a blocks which is connected to some pulleys, right? So only thing what you can do is you have to identify what is the particular length of the particular thread, right? So wherever and locate what are the constants, then you differentiate with respect to time, so automatically it will eliminate, so only the variable will be there. Based on that we can find out. For better understanding purpose, we will see a few more figures and we will identify what will be the velocities and acceleration for that. And we consider this. So you have two blocks, so you can able to see here. So one block A is having connected to only one particular thread, whereas block B it is connected by two threads, right? So but anyway, don't need to worry about it. So only thing is you have to identify the length of the thread, right? So the length, choosing the length is also a factor. You should choose the length which will affect the movement of these two blocks, both the blocks, right? So I said that this is one thread, extra thread. So if what happens is that it is a constant one, it won't affect this one, right? So the main thread which is affecting is this one, so which is passing over these things, right? That is the only thread which is affecting this entire one. So you will concentrate only on this thing. Okay, so I will draw a data plane here. So I will mention this as SA and similarly this as SB. So whichever other things we will consider as a constant. So I can say this L, length of the thread L is equal to, so here 1 SA, so SA, right? And 1, 2, 3 SB, so plus 3 SB, right? So plus constants. Constants is indicating whatever which is in red color. Okay. So in that case, if you differentiate this, what will get? I will get VA is equal to minus 3 VB. And of course, again, if you differentiate, I'll get AA is equal to minus 3 AB. Right. Then we proceed with another one. So it's a problem here. So you have to determine what is the velocity of block A, right? So if end is applied a force, so a velocity of 6 meter per second. Okay. So this will be the problem. So what I have to do, I have to take a datum plane. So what I can do, I will draw a datum plane like this. So this is my datum plane. So something like this. Okay. So this is a constant, right? Let me call this as A. So up to this. And from here to here, let me call this as SA. So movement of, this is the main part of moving this. And this one is fixed, right? It is not moving, right? So I will call this as H, height H, right? I will call this as height H. And you have this one, let me call this as B. So if I can't identify what is the length of my thread, length will be equal to this A plus from here to here SA, and then again from here to here it is moving like this. So 2 SA, 2 SA, and up to here, from here to here it is H, again it is moving, so plus 2H, right? And the last B, right? So this is my overall length. So neglecting the length on the pulley, so you no need to consider that. Okay. So in this case, let us identify what are the constants and what are the variables. The length of this string is always constant. A is always constant. There is no change, but SA will vary, right? If there is a change in A, automatically SA will vary. So this is a variable, right? This is a variable. So other things are all constants, right? So let me consider this B, right? So B is the force which is acting. You consider this as one particular object. Let me call this as a B. Instead of B, you will call it as SB. Okay. So because we are pulling here, so you consider that there is an object which is pulling, right? So in that case, SB is also a variable here, right? and 2h is a constant. It is always constant, but this is fixed. Okay, so when I differentiate this, what I will get? I will get 2 0 is equal to 2 VA plus VB, or I can say that VB is equal to minus 2 VA. Right, but our aim is to identify VA, so I will put it in another way, right? So VA 2 VA is equal to minus VB, or VA I can able to get as minus VB by 2, right? So they are given VB, so the velocity at this block, the hand which is pushing is 6 meter per second. So in that case, VA will be equal to 3 meter, minus 3 meter per second. Minus indicates in opposite direction. Any doubt? So this block will be moving upward direction at 3 meter per second. Okay, let me consider this one, right? So again, so you consider this as one block, right? VF. So block F. Okay, so this is block F. Okay, so this is block A. So again, I will draw a data plane here. So extra A, right? And from here to here, I don't know which is SA. And from here to here, this data plane, I will call it as SF. Okay, so now what I can say, length L is equal to A plus 1, 2, 3, 4, 4 SA, right? 4 SA, right? Plus SF. This is my overall length. So differentiate this, you'll get 0 is equal to, so of course, you can identify. So these are the constant. These two are variable, right? So you can easily identify. So 0 plus 4 VA plus VF, right? So we are asking you to identify what is block A, right? So which means VA I want. So VA is equal to minus VF by 4, right? Which is equal to minus 3 by 4 meter per second, right? This is another way, right? So these are the things which you have to consider, right? So when it is connected to some sets of pulleys to identify what is your velocity and accelerations, right? Okay, we will proceed now. We will proceed with that problem. So this is the prerequisite for that particular problem. So you have to know how to identify that velocity differences, right? So you have a block. So one block is on a horizontal plane, other block is hanging, so which is connected to a pulley, right? It's connected to the pulley, and they are given acceleration is g by 9, so which is nothing but okay. So the acceleration of 10 kg is moving at g by 9. So they mentioned like that. Okay. So it says that you have a mass of 10 kg on a rough horizontal plane. So it is connected to a string, right? So then it is connected to 5 kg. So what they said is when 10 kg block is released, it moves at g by 9. So which is 9.81 by 9. Okay. So they are asking you what is the value of the coefficient of friction. They are asking you what is mu value between this, right? That is the question, right? So what will be the mu value for this, right? So other things you can able to identify, right? So the first thing is, let us identify what is the relation, right, with these blocks. Okay. So since it is connected to this A, so what I can do is I will consider up to this. Up to this is SA. Okay, so then I will draw a datum plane. So this one is SB, right? So, and the last one is, let me consider this as P, some value P. So if I consider what is the length L, L will be equal to SA plus, so 2 times SB plus P, right? So when I consider here, these are variables, these two are variables, these two are constants. I'll get 0 is equal to VA plus 2VB, right? Or I can able to get that VA is equal to minus 2VB, right? Similarly, I can also say that AA is equal to minus 2AB, right? These are the terms. So now I know what is AA. So what is AA? So acceleration of block A, which is 10 kg block. So block A acceleration is G by 9. So where G is the acceleration due to gravity. So which means 9 by 9.81 divided by 9. So we're getting 1.09, right? So meter per second square. So acceleration for block A is 1.09 meter per second square. Okay. And you can also identify the direction. So I assume that this block is moving towards this direction, right? This block is moving about this direction. What about your block B? It will be moving downward direction. Yes. So when this is moving like this will go down, right? So this is the direction. So direction of motion, right? So this is the direction of motion, right? So what I can do, so you can able to identify. So AA I identified. Let me identify AB. What is the block acceleration? Acceleration of block B. So acceleration of block B is AA by 2 minus AA by 2, right? So no need to worry about the negative sign. Negative sign always indicates the direction. So upward direction is positive, downward is negative. So that's what it was coming like this. So of course the direction is different here, right? No need to worry about it. Okay, so you leave the negative signs. Okay, so directly you identify what is AB. So AB is so 1.09 divided by 12.
0.545.
So AB is 0.545, right? Meter per second square. Okay. So I'm going to solve in only one method. So I'm not going to repeat it again and again. So because you can understand the concept, which method we can solve? You tell any one method, we will try to solve. D'Alembert's principle or work energy or impulse momentum, whichever you feel. Okay, so let me try it out in solving it by work energy. So when I go in work energy method, right? So you have to identify what is the um, free body diagram for A and B. So let me consider for A first, right? So for A, you have a rectangular shape. Okay, so you have a rectangular shape, and you know that it is connected to a string. So you have T. So they called as T. So I will call as T itself. Okay, this is T. Okay. So next, you have a weight which is acting downward. So your weight which is acting downward, which is 9.81. So actually, it is in kilogram. You have to convert it to Newton. So 10 into 9.81, you'll get 98.1 Newton, right? And they said that this is a rough surface. This is a rough surface. So for a rough surface, you will have a reaction, contact reaction RA, and opposite to the direction of motion. So this is moving along this direction, right? So opposite to that direction, you will have that friction, right? Which is mu into RA. So friction is mu into RA. So our aim is to identify this mu and what is the tension, right? So these are my free body diagram. Okay. So one step to identify here. So you know that here in this case, sigma fx is not equal to 0 because you have a movement in x direction, right? So this direction movement is there, it is not equal to 0. But sigma Fy is equal to 0, right? So sigma Fy is 0. If I equate it, so I will get Ra is equal to 98.1. So Ra is equal to 98.1. So now let us identify what is sigma Fx then, right? So the direction of motion is along this direction. So that will be considered as positive x. Okay. So what is sigma fx? So sigma fx is t minus zero point 0.3. Sorry, I am thinking of mu as 0.3. Okay, sorry. So T minus mu into 98.1. Right, this is my sigma fx. Okay, now what I can do, I can able to identify what is the work done. So work done is T minus mu into 9.81, so 98.1. Right, so now let us go for energy. So energy is half mv square. So we have only kinetic energy, which is half into 10 into va square. Okay, so m is 10, right? So in that case, I will get 5 va square. So I can say that work done is equal to energy. So I can equate it. T minus 98.1 mu SA is equal to 5 va square. Let me consider this as equation 1. Okay. Now we'll proceed with the next block, block B. Let me go for block B. So when I consider block B, right, it is connected to a string. Okay, so it is connected to a string. So something like this, right? And your block is here, 5 kg, right? So you have two tensile forces which is acting like this. Okay, so this 5 I can make it as, so 5 into 9.81 because I need it in Newton. So in that case, instead of this, what I can get, I will get, so it is 49.05 Newton. Okay. So when I consider here, it is like you have 2t on upward direction and then you have 49.05 on the downward direction. Okay. But this block is moving. That is very, very important. This block is moving. In that case, I can't equate it. So it is not equilibrium, right? So since the block is moving downwards, so the downward direction will be considered as positive one. Okay. So what I can do, I can just directly put sigma Fy is equal to 0. Sigma Fy is equal to 0. Sorry, it's not equal to 0. Right. So which means sigma Fy is equal to 49.05 minus 2t. Right. So let us identify what is the work done. So work done is equal to 49.05 minus 2t into SB, right? Into SB. So this is my work done. So next, what we are going to identify is, let us identify what is our energy. Energy is half me square, which is half into 5 into VB square, right? So you will get 2.5 VB square. So we can equate it now. So when I equate, I will get 49.05 minus 2t into SB is equal to 2.5 VB square. Equation 2, right? So now what I can do, I can divide 1 divided by 2, right? You can divide these two equations divided by 2.5 VB square. Okay. So now, Amanda, my yeah, right. Now, let us consider this equation. So you know that SA, right? What is SA in this case? What we identified at the beginning stage, right? Your SA is 2 times of SB, right? Don't need to worry about negative sign. Already I told you, so SA is 2 times of SB. Similarly, VA is 2 times of VB. And you substitute, be careful in this, you have to substitute accordingly, right? In this case, what you'll get, so T minus 98.1 mu SA divided by 49.05 minus 2t into 2, sorry, I think yes, yeah, I can put it as 2, right? Sorry. So this is SB. So this is SB and this is 2 into SB, right? Is equal to 5 into 4, 4 VB square divided by 2.5 VB square. Okay, so that I can get cancel. I can cancel these things. Okay, so what are the other terms? So you'll get T minus 98.1 mu divided by 49.05 minus 2T is equal to, so 20 divided by 2.5. Okay, any doubt on this?
Sir, into
I
2
think,
is there in the numerator, sir.
sorry, I missed that two. Yeah, this two. Yeah, okay. So now you cross multiply. So let us bring T on one side and mu on the other side. Okay, so that it is easy for solving it. Okay, so what I'll get, I will get 20 into 49.05 minus 2t is equal to, so 5 into t minus 98.1 mu, right? I am cross multiplying. 2.5 into 2 is 5. Okay, so 981 minus 40t is equal to 5t minus, so 98.1 into 5. So we're getting 490.5 mu, right? So bring this on one side, right? So you'll get 45t is equal to, so 981 plus 490.5 mu. So this is what I am getting as an equation. Okay. Even if I simplify, I will get t is equal to 981 plus 490.5 mu divided by 45. Okay, I will consider this as equation 3. Okay, so now I got this equation. Substitute in any one of the equations, either equation 1 or equation 2, right? So let me substitute in equation 2, right? Let me substitute in equation 2. So here, here let us substitute what will be the values accordingly, right? So I'll get some terms, right, in terms of SB and VB. Okay, so right, so you know one relation. So first let us identify what is that relation and let us identify the values with respect to that. Okay, so at the beginning itself we identify what is your acceleration and what is your acceleration for A and B, right? Acceleration for block A is 1.09 and B is 0.545, right? So because they mentioned it. Okay, so since we are solving equation 2, I am concentrating on acceleration for block B. So acceleration for B is 0.545 meter per second square. So now let us identify. If I get acceleration as 0.545, right? So what will be your other values? What will be your velocity and what will be your distance? Because we have relation in terms of that. Okay. So again, we use the same formula. So you can able to see that the best suitable formula here is this, the last formula, v square is equal to u square plus 2as, right? So your initial velocity, the final velocity is v square, we don't know. Initial velocity is 0 plus 2 into your acceleration is 0.545 into s. So this is for block B, right? So this is my block B. So in that case, VB square, right? VB square will be equal to 1.09 SB. I got this relation. Use this relation here, right? Use this relation here. Okay. So what I'll get? So I'll get 49 point, before substituting, I am doing this 0.5 minus 2t, right? So this is SB is equal to 2.5 into 1.05 SB. So your SB gets cancelled, right? So you can easily identify what is the value of T now, right? So before substituting it. Afterwards, we can substitute to identify what is the mu value, right? So just cross multiply. So what will get 49.05 minus 2t is equal to, so 2.5 into 1.09. So I'll get 2.725, right? So just cross multiply, 2t will be equal to 49.05 minus 2.725, right? So totally you will get 46.325. So you will get the value of T, 23.16 Newton. Good. So we identify the T value. Now I think this step is not reader. I can erase this, right? Instead of this as equation 3, better I will put this as equation 3 because it is more convenient to solve. Let me substitute this in equation 3 into 23.16 is equal to 981 plus 490.5 mu. So what is the value of mu? So you'll get 0.125. Are you getting it?
Yes, sir.
Yes, sir.
Right? So this is the value of mu. Right? So you can also solve the same problem in any other method, whatever it is convenient. Okay, you can try it out. Okay, you can try it out. You find out how to do this. Right? Related to this, let us consider this one. Okay, so this one you have a wooden block, right, of 80 kg. It is starting to slide from the rest A with a 30 degree. So this is 30 degree, right? 30 degree frictionless inclined plane. Okay, it touches the spring and comes back to rest at B. So after that, so the stiffness of the spring is given. So they are asking what is the maximum compression of the spring, right? So let me consider here. So let me consider. So this is my inclination, right? This is my inclined plane. So this is 30 degree that is mentioned. Okay. So you have a block here, right? This is your block which is available here. Okay. So the weight of the block is given, which is 80 kg, right? And this point, you have a spring. Okay. So you have a spring which is attached to this, something like this, right? So what happens is, so it hits this and there is a compression in the spring. Okay. There is a compression in the spring. I think one data is missing, which is the distance. So I think let me consider 5 meter. Just a minute. Look after the book. Yeah, it is 5 meter. It is given as 5 meter. Okay, so this is 5 meter. So the diagram is given. So in the question itself, so it is 5 meter apart. Okay. So after that, what happens? It applies a spring. So when you apply the spring, what happens? The spring will deflect. So it will compress to a distance of x. Okay. So they are asking what is the compression, right? What is the compression? Now, which method we can solve this? Already told you, I think so. 2 plus before.
Work energy.
Yeah, very good. So we can solve only by work energy method. You can't solve in any other method. Okay, so whenever you have a spring, concentrate only on work energy method. Okay, so when you consider spring, so make sure, right? you have kinetic energy in the spring. So the kinetic energy is of minus of k into x square, right? So why this negative? Because so when it is compressed, there is an opposing force which is acting on the body, which will make it to move. So once you release that block, what happens? It comes to its original position, right? So that's why. So the kinetic. So even though the block is moving along this direction, this is my x direction, right? The block will be moving along positive x, but the spring force is opposite direction, which will restrict the motion. Okay, so since that is in opposite direction, you are putting that negative sign. Okay, so kinetic energy is off into k. K is the stiffness of the spring. So this is stiffness, right? So which is in Newton per meter, and this is the deflection, how much it is deflected, right? So if I consider the spring will be normally, for example, 10 mm. So once the block is acting, it will be 4 mm, right? So 10 minus 4, right? Remaining 6 mm will be the deflection, something like that. Okay, so that is your deflection. Okay, the spring kinetic energy is this. Okay, so work done for the spring is always zero, right? Because what happens when you press, so both are at resting state. So mostly the work done for the spring will be zero, because it will always make the spring to an equilibrium state. Okay, so you consider this kinetic energy is always off into m into k x square, and work done is always zero, right? So now we will proceed with this. So let me consider this block. Okay, I will draw the free body diagram for this block. Okay, so if I draw the free body diagram, so this is my block, right? So this is my block. So what are the force you have? So the block is it is resting here. So see, for information, I am giving you this inclination. This is my inclination, right? 30-degree inclination. Okay, so it is resting here. So you have force, reaction force, right? Ra, right? Which is what I can say. It is always inclined at 30-degree to the vertical. Right? If this is horizontal, then this will be vertical, right? And you have a weight of the block, right? Weight is 80. So 80 into 9.81. What is 80 into 9.81? 784.8. So you will have 784.8 Newton, right? So these are the two forces. So, and you know that the block is moving along this direction, right? As I told you, so again, there will be a confusion here to identify the spring force and other things. So what I'm going to consider is, I'm going to consider this block, right? So I'm going to consider this and this. This is my x-axis. This is my y-axis. Okay. So inclined in an inclined manner. So now if I go in to consider what is my graph for this, okay. So what I will get, so you can able to see that this is 30-degree, right? So this is 30-degree. So which means this side will be 30-degree. Okay, so you can able to see this is my third angle of position, which is 784.8. This angle is 30-degree, right? Right. So other than this, you have RA, which is straight. Okay. So the thing is, now what I have to do, I am going to consider it is not in equilibrium state along the direction of the motion. So which direction? Along this x direction. So this is my positive x, right? This direction. Okay. So let me identify what is sigma fx. So sigma fx is no need to consider this RA and all. So just directly do it. So 784.8 sine 30. 392.4 Newton, right? So now I will get what is my work done. So work done is 392.4 into distance, right? Distance. Let me consider SA. Okay. So if I consider what is SA, so your block is moving for 5 plus this X distance. What is that X? It when it get compressed. So compress ஆயிட்ட பிறகு தான் நிக்குது block, right? Up to that you have work done. So your SA is nothing but 5 plus X. Okay. So in that case, my work done is 392.4 into 5 plus X. Okay, this is my overall work done. Okay. What is my kinetic energy for the block? Actually, the kinetic energy is of mv square minus of mu square. So initial final velocity minus initial velocity. Initially, your block is at rest. Finally, yeah, it is zero because rest ஆயிடுச்சு இல்லையா? So spring compress ஆகி rest ஆயிடுது. So final velocity and initial velocity both are zero. So it means my kinetic energy is zero here. Okay, so this is my first part, right? So actually this is only for block. I am considering only for block. So இதுவே வந்து work done is equal to kinetic energy போட்டுறக்கூடாது. So you have spring also. You concentrate on spring. So next I am going for spring. Spring, you have kinetic energy which is equal to half kx square. K is already given, which is 2000 into s square. So x square, I don't know the deflection, right? So which means I will get minus 1000 x square. So what is your work done in your spring? That is zero. Your work done in your spring is zero. Now I will identify. So work done, total work done is equal to total kinetic energy. Total work done is work done for the spring plus work done for the block. Right? Work done for the block is around 394.4, 392.4 into x plus 5, right? Is equal to kinetic energy. So when I consider kinetic energy for the block is zero, right? Kinetic energy for the block is zero, plus you have kinetic energy for the spring, right? So kinetic energy for the spring is minus 1000 x square, right? Okay, so now let us equate it. So what you'll get, I will get 392.4x plus, so 392 into 5, 1962, right? Is equal to minus 1000 x square. So bring it on the other side. So 1000 x square plus 392.4x plus 1962 is equal to 0. So can you solve this?
Sir, minus 0.1962.
என்ன வருது maximum? What is the maximum compression on the spring? Okay, any doubt in this? Any doubt in this?